Hey y'all, Miss Kennedy here from Algebra Student, and today we're looking at the entire Polynomials unit for Algebra 1, everything that you see on the screen from the vocabulary to finding greatest common factor and all those things in between. So what I've done for this particular video is I have made a PDF that you can download that's just the examples that we're going to go through together. So it's laid out so that it's easy to print. So if you want to pause and click on the link in the description, you don't have to sign up for anything. You just go to that link and scroll down and you'll see the PDF that you can download. And then you can print it out so that, if you want to have it in front of you as we go, almost like you're taking notes, or if you're like reviewing for a test and you want to go ahead and just like try to work them all out and then watch the rest of the video. It's up to you, do what works for you, because this is, you're in charge of the learning here. So, so go do that and I'll be right here while you're doing that. Okay. So let's take a look at the first part. Let's just jump right in. It says that we're going to write these in descending order, identify the degree and the leading coefficient. So this is how I'm going to talk to you about the vocabulary, is we're just going to actually look at some problems and see what in the world these three things mean. So descending order, when you're in algebra, and as you keep going with algebra 2 and college algebra, pre-cal, all those things that you're going to do, you've got to have things in descending order most of the time. That's going to be pretty important, and it's not a big deal. Descending order just means look at your exponents, those little numbers at the top, and put them in order from the biggest to the smallest. And so if we look at descending order and we look at the very first problem here, we can see that it's already in descending order because this is x cubed and this is x to the first. There's a little understood 1 there. And so the 3 is first, the 1 is next, there's nothing else. So it's already in descending order. Let's look at the one on the right. We've got n to the second, or n squared, and we have a 6 that doesn't even have an n. Technically that's n to the 0, but it just there's no n, there's no variable. And then we have n to the first again, understood 1. So that we need to rearrange. So negative 9n squared does come first because that's the biggest exponent. And then your next biggest exponent is the 6n, so plus 6n, and then the 6. The 6 has, like I said, an exponent of n to the 0 because anything to the 0 power equals 1, and 6 times 1 is 6. You don't have to know that. Just know that the constant, the number that's just a number, is going to come at the end. Okay. All right. So let's look at the next one here. Biggest exponent is 4. So that one comes first, 2a to the 4th. And then we have this a to the first, so we'll put that next, minus 2a, and then we have a plus 2. And that's our descending order. So 4th, first, and then none, no variable. All right, so here we have 5, 4, 3, and 6, and we just want to put them in order so that 6, 5, 4, 3. We want the variable for the exponent to start with the biggest and go to the smallest. So it's a negative 3p to the 6th minus 8p to the 5th minus 6p to the 4th minus 7p cubed. All righty. Okay, so we have done the descending order part. Got that. Identify the degree and the leading coefficient. Okay, so the degree is whatever your biggest exponent is. And by writing it in descending order, it makes it that much easier to find because it's the very first exponent that you see. So the degree here is 3 because the exponent for the variable is 3. That's the biggest one. Okay, so what's the degree for the next one? The degree is 2 because that's the biggest exponent on a variable. The degree here is 4, 2a to the 4th, and the degree here is 6 because it is negative 3p to the 6th power. Okay. The leading coefficient, we usually write that as LC, just to save a little time. And the leading coefficient is the number in front of that greatest degree, that first term. Okay, so the leading coefficient here is 7 because it's 7 times x cubed. Coefficient is just the number that's being multiplied by that variable. Okay, so the leading coefficient on the next one is -9. And the leading coefficient here is 2. And the leading coefficient on the last one is -3. So it's kind of good that that we were told to put it in descending order, but honestly, if you've got to find the degree and the leading coefficient, then whether it even asks you or not, go ahead and put it in descending order, because then it's just straightforward, super, you just know it's that very first term. If it's in descending order, the first term is going to have the leading coefficient and the degree right there in it. Okay. All right. So got some vocab out of the way. Now let's look at this. Simplify each expression. And when I look at these, I see, like, first of all, I see lots of terms. Like, there's a whole lot in each problem. I see parentheses, 2 sets of parentheses in all 4 of these problems. And I see that in between the parentheses, there's a symbol. Like, there's either a plus or a minus, and there's 1 plus and 3 minuses. The reason for that is that the minuses, you have to do something extra. So we're going to practice that a little more. But yeah, so we're adding or subtracting. So, sometimes this will be called adding and subtracting polynomials. So if you're, if you printed the download at the beginning and you're kind of taking notes here, that might be what your notes are called from that section from your own class, or textbook section, if you're trying to kind of look and see what it's like. All right. So if we're adding and subtracting, we're essentially combining like terms, like just putting the like terms together. And the only difference is that if it's subtraction, there's this extra step that we have to take. So if there's addition in between the 2 sets of parentheses, that means that you don't do anything except combine like terms. So in this case, I ignore the parentheses and I'm combining like terms. For instance, I see an n to the third and an n to the third. Okay, I'm keeping the sign in front of it with it. So I've got a plus 5 and a -8, or 5 minus 8, which is -3. And the reason I'm doing that one first, think about what we just did in this previous section. We wanted it in descending order, and so that's why I'm doing this first, is because I want that n cubed to be at the beginning, at the front of the answer. Because when we write our answer, if it's not in descending order, then we need to rearrange it and put it in descending order. So if it's a shorter problem like this first one, where there's just 4 terms to kind of combine, you can probably just go ahead and put it in the right order and save yourself a step. So that's kind of nice. And then we have a 4 and a 6, and they're just numbers. So you just add those together. 4 plus 6 is 10. And we've got the answer to our first problem in the second section. All right. It's in descending order and we're good. Okay. So now we're into ones where it's subtraction, and I told you there's this extra step to do, because I want you to realize or think about that there's an understood 1 here. There was an understood 1 here too, but think about it. If you multiply +1 times anything, you get that anything. You get what you started with. 20 times 1 is 20. 1,000,000 times 1 is 1,000,000. -6 times 1 is -6. Like, it doesn't change anything. But if we multiply by a -1, and you've got to think about the distributive property, then it changes things. So it changes the signs. So we've got here, we don't have anything in front. So it's just 5n to the 4th minus 3. I'm just bringing it down. Okay. And here we're going to multiply that -1. So -1 times 5 is -5. -1 times -4 is +4. into the fourth. Okay. Now, we've dealt with the parentheses, so we don't have to keep writing them. At this point, the parentheses is not needed. It's not there. So don't write it. Don't keep bringing it down. All right. And now we're back to exactly what we did on the first problem, and we're just going to combine like terms. So I see an n to the fourth here and an n to the fourth here. All right. So 5 plus 4 is 9. So 9 n to the fourth. And -3 and -5 is -8. And that's my answer. Again, we've already got it in descending order because we started with that n to the fourth. And then the only thing that was left was a regular number called a constant. Okay. All right. So let's move on. The same idea here. We've got a set of parentheses here, and there's nothing in front of it. So there's nothing to do to clean that up or to simplify it. I'm just going to bring it down. Copy, bring it down, exactly like it is. Here we've got a -1, so we have to distribute that. So -1 times 2m to the fourth is just -2m to the fourth. You know, -1 times 2, -2. All right, -1 times 6 is -6, and that's an m squared term. -1 times -6 is +6, and that's an m cubed term. Okay, so you're possibly noticing some things that are happening every time. That's fine. I'm going to show you what works every time because I think that that's the best way to learn math is to do the things that are going to work every time so that you don't have to remember, oh, but sometimes do this and sometimes do that. As much as you can, try to do what works all the time. All right, I've circled the m to the fourths because I want those to go in front for my answer. So 8 minus 2, that's 6m to the fourth. I've got an m cubed here and an m cubed here. So 7 plus 6, that's 13. M cubed. And then I've got an m squared and a -6m squared. And so I just need to remember this is 1. If there's not a number there, it's just one of them. So 1 minus 6, that's -5m squared. Okay. All right, I'm in order, descending order, m to the fourth, m to the third, m to the second. So we're good. All right, so we're ready to move to the next one. Let's see here. We've got parentheses, but there's nothing in front that would change anything inside the parentheses. So I'm just going to bring it down without the parentheses. And then we've got a minus sign here. So remember to multiply, distribute. -1 times 4 is -4, and that's an n term. -1 times -3 is +3, and that's an n to the fourth. And -1 times -7 is +7, and it's just a number. There's no variable. So good there. All right, here's an n to the fourth. And here's an n to the fourth. I'm combining these like terms. So 3 minus 2 is 1 n to the fourth, but we would just write n to the fourth. You're not going to write the 1 out in front in your final answer. Here's an n term and another n term. So -5 minus 4 is -9n. And then we've got 4 plus 7. 7 plus 4 is 11. So there is our answer. So n to the fourth, and then an n, and then a number. Descending order, so it's a complete, it's a final answer there. All right, we're moving right along. This is great. Now, let's see here. It says find each product. Okay, so this is multiplying polynomials in this section. So if you downloaded the examples, then you can add that if you think it'll help you to find it in your notes from your own class or from your textbook or whatever. All right, so multiplying polynomials. Now, these can get very long. Excuse me. Ooh, that was probably not pretty to listen to. So like when I say long, like trinomial times another trinomial, which is sometimes vocabulary for this section. Trinomial, like a tricycle, has 3 wheels. That just means that it's a polynomial that has 3 parts, 3 terms inside of it. And so like this is a trinomial, for instance, right here. This is a trinomial. It's got an x squared, an x, and a 6 term, so constant term. All right. So sometimes you're going to have to do even up to trinomials times trinomials, but you'll do the same process that we're going to do here. I'm not going to show those. If you need some of those, then please comment and let me know that, because I'll be glad to do some of those. But it is the same process that you'll do here. You would just add that third term to the process that you're doing. All right, so let's jump into this. For the first ones, to me, I just think of this as distributive property. I'm just going to distribute like we were doing in the previous problems here, where we distributed over and over again. We were doing essentially what we're going to do here. It's just that'll be our answer once we do. Well, as long as it's in descending order. Okay, so 8 times 7 is 56, and then that's an n squared term. 8 times negative 5 is negative 40, and that's an n term. 8 times negative 1 is negative 8. And I just need to make sure it's descending. Squared, 1, and none. So that is done. All right. Let's do one more. 7 times 7 is 49. That's an x squared term. 7 times negative 4 is negative 28. That's an x term. And then 7 times 6 is 42. Check our exponents for descending order. We got to the second power, to the first power, and then no no variable. So there's our second answer. All right. Good. So let's look now at multiplying these polynomials. Now, these are called binomials, just like a bicycle has 2 wheels. Binomials have 2 parts or 2 terms. So this is a binomial here, and this is a binomial here in the parentheses. So binomial 1, binomial 2. That's what I'm saying. All right. So what we're going to do is we're going to do that distributive property again. And we're going to set it up in a way that I think by stacking the like terms, I think it has made a big difference for all of my students who struggled with this and were like putting stuff in the wrong places and skipping stuff and missing stuff. So what we're going to do is, because this is parentheses, and notice there's nothing in between the parentheses there. There's no symbol in between like before, where we had a plus or a minus. Like up here, you had the plus or the minus in between. Here, there's nothing in between. And so let me erase some of those little marks. Okay. All right. So what we're going to do is we're going to distribute the 5k times the 6k minus 5. So 5k times 6k. 5 times 6 is 30. And we haven't done this before. K times k is k squared. Because when you're multiplying them together, you have to add the exponents up. So there's a k there and a k there. 1 and 1. So that makes 2. So k squared. Now let's distribute. We did 5 times 6. Now let's do 5 times negative 5. So 5 times negative 5 is negative 25. And that's a k term because that had a k on it. Okay, so we're done. We distributed the 5k to that second binomial. Now let's do the same thing with the negative 3. Let's distribute it. So negative 3 times 6k. Well, negative 3 times 6 is negative 18, and that's a k term. So think, am I going to put it under the 30k squared or under the negative 25k? I'm going to put it under the one that it's alike, or like. Which word would that be? Yeah, like. Okay. Negative 18k is going to go here under the other k term. Okay. Ha. Oh my goodness. All right. So negative 3 times negative 5, that's positive 15. And I'm putting it next because it's just a number. And this is a k squared term. These are k terms. And this is just a number. It's a constant. It doesn't have a variable. So it wouldn't combine with those. Now, I like to draw a line to show that I'm going to add these up. I'm going to, get my totals, so to speak, for the columns. Oh, that's nice. All right, come back. Oh, mercy. Now you're too big. If anybody knows what I'm doing that's making it do this, because I have Googled and I can't figure out how to lock it in so that I stop doing it. It's something to do with this pen, I'm sure. But I've changed all the settings on like the little buttons, like they're disabled, I think. But anyway, okay, here we go. So I'm just going to bring this down because there's nothing to combine. We've got a 30k squared term. And then these we can add together. So negative 25 minus 18 is negative 43k. And then I just have a 15. I don't have anything to combine it with. So plus 15. Now, as long as that's in descending order, we're done. And so we can check, and we've got a k squared and then a k and then a number. So yep, we're in descending order. That's it. Now, there are lots of other methods for this. This one is called double distribution. At least that's what I call it. I don't know what else it might be called, but there's a window method, there's a box method, or your parents most likely learned what I learned, and that's called the FOIL method. They all work. If you have been doing this in class and this was fine and you've been doing it a different way, then use that way. Like, don't change because you saw this here. But if you've been struggling with it, or if you haven't learned it yet and you're just kind of getting a preview, then I found that this was really helpful to students. So, and oftentimes I think too, whatever you learn first is what you tend to like a lot of times. So whichever, that's all good. You'll get the same answer I will if you do the FOIL method or the window method or the box method. We just get there in different routes, but we get the same answer. So it's all good. All right, so let's do double distribution with this next one. So I'm going to multiply the 2x times 6x, and 2 times 6 is 12, and x times x is x squared. Just like it was before, k times k was k squared. All right, let's distribute the next one. 2x times negative 7. 2 times negative 7 is negative 14, and that has an x on it. All right, now let's distribute the 7. 7 times 6 is 42, and that's an x. So I know not to put it under x squared. I want to put it here, 42x. And then 7 times a negative 7 is negative 49, and neither one of those has an x, so the negative 49 doesn't have an x. All right, draw my line, and I'm just going to bring down the 12x squared. I'm going to combine these, and this is a positive. If it helps you to think about it with a plus in front, that's fine. You can always put the plus in front of it. So 42 minus 14, it's an x term. And let's make sure I've got that right. 28, 38, 39, 40, 41, 42. All right. It's a good time to mention. If I mention it, then I've got to do it, right? So one of the things that I'm considering doing is a 30-day challenge for myself, because subtraction is something that I've always told my students, I can't subtract in my head very well at all, and I can't count. Like that's a running joke that if you're in my classroom, you know about the not counting, but subtracting really is like a challenge for me. Like, I mean, yes, I can do it and I can think through it, but I'm not automatic with it. And you'd think, oh, math teacher, she's going to be like, oh, a whiz at that or whatever. And I'm not. So I'm just tired of saying that. So I'm gonna do it. I'm gonna start. I'm gonna get myself I'm gonna get some problems. I'm gonna test myself. Like initially see how many problems I can do in a certain amount of time. And then every day for 30 days, I'm going to practice for, 3 minutes a day, like flashcards or something. Like I'm in second grade. I don't care. That's what I'm going to do. And then at the end of the 30 days, I'm going to do that same test again and just see if I can do more problems after 30 days than I could at the beginning. So that's look for that from Algebra student. I don't know. It's a funny little silly thing for a math nerd like me to want to do, but that's what I'm doing. All right, here we go. Now, this is the same section. This is still multiplying polynomials, but sometimes it looks like this. And don't let the way it looks at the beginning throw you off. That little squared symbol right here, all that means is that you're taking this binomial 5m plus 4 and you're multiplying it by itself, 5m plus 4. That's it. That is all that means. So it's the same exact problem as what we've been doing, except that both of the terms are the same thing. Okay. So I'm going to do the same thing I've been doing. I'm going to do 5m times 5m, 25. M times m is m squared. Bet you're a pro at that by now. 5m times 4 is 20m. 4 times 5m is 20m. Interesting. And 4 times 4 is 16. Now, you might have learned a shortcut or a trick or something like that with some problems. There is a pattern that you'll see if you do enough of these types of problems called perfect squares. I have found over the years that students don't do well with this trick or shortcut. They try to remember it and they still miss it because they forget like a part or a piece of it. And so I'm going to go back to what I said earlier and say that if you'll just do this the same way every time, you're much more likely to get it right. So I'm not going to go into the other. I would if I really thought that it'd be helpful. I mean, I'm all about a shortcut if it works every time, but I've just not seen that it was very helpful to students. So, all right, bringing down the m squared term, I'm going to add these two together because they're like terms. 20 and 20 is 40. And that's an m term, and then bring down the number 16. All right, descending order, m squared, m, and a number. Yep, good to go. All right, that's my answer. That's it. Okay, so now we're on the last section, and honestly, this is a tough part. And there's, it's not just that it can be tough. I'm going to show you some things that I think are good strategies that I hope will be really helpful to you to make it a lot easier and more straightforward. I'm going to open up my calculator, by the way, while I'm doing that. So, oh yeah, I gotta get that. All right. Oh, lightning. I hope it doesn't cut us off. Actually, I didn't hear lightning. I heard thunder. Oh my goodness, that was funny. Okay, let me put this in front so it doesn't go away, even though it's going to blink and it might aggravate us. Okay. Oh, I think this is where I was going a minute ago. Sorry about that. So this is going to be really important in the next unit of Algebra 1 because you're going to jump into factoring most likely, and you've got to know how to find a GCF, greatest common factor, when you are factoring. I mean, it is the first step. So it's pretty important. So GCF, greatest common factor. Now, most of you probably have heard of that for a long time, and you found it, it's one of those elementary school things that you had to do, and it's not really attached to anything in a lot of classes. Maybe it was for you, but I find that students are still struggling with this a lot in high school. It's just still like really tough. And so, especially now, because now you're not just factoring the numbers, you're factoring the letters, the variables. And so it's like you've got extra to do. So in your brain, I want you to think of those two as separate things because you got to figure out the GCF for the numbers, and then you got to figure out the GCF for the variables. And it's a different process, and they don't really, they end up going together in their answer, but you think through them separately. Okay. So think through them on their own. So the first two are just binomials. You see how this just has a 4x to the fourth and a negative 12x squared. It's just got the two terms in it. And then the next one's got a 2 and a 4. So if you are, I should have used bigger numbers, shouldn't I? If you already kind of are thinking, oh, I think I know what this is, then go along with me just to learn the process that I'm going to say. And the reason I pulled up my calculator is if you've got just two numbers, especially, I would go ahead and type in those two numbers as a fraction. So 4, and then that N over D button is the fraction, and then hit enter. And so 4 over 12 reduces to 1 over 3. So how in the world does that help you with GCF? Well, that's saying that they'll both divide by something, and so that you'll end up with a 1 and a 3 where you had a 4 and a 12. So you can think through that, or you can say, okay, well, I'm going to take the top number 4 and divide by the top number that it ended up with and hit enter, and that's your GCF for these two numbers. So if you had taken the bottom number 12 and divided by the bottom number on the right, 3, and hit enter, you get 4, right? So GCF here is 4 for the number part. So remember I said we got the numbers and we got the variables. All right. So now let's think about the variables. And there's a couple of ways to think about it. Over here in the first part, we've got x to the fourth, which is 4 x's multiplied together, but there's 4 of them, right? Here we've got 2 of them because we've got x squared. So to the second power, that means x times x. And we've just done problems where we did m times m and got m squared. We did x times x and got x squared. So you know that x squared is 2 x's multiplied together. Okay, so the thing that you're looking for is what's the greatest, the biggest thing they have in common. So there are 2 x's here and 2 x's here. That's the most they can have in common is 2 of them, because even though there's 4 over here, there's only 2 here, so they don't have that in common. They just have the 2 in common. So I'm going to put 4x squared because it's 2 of the x's they have in common, and those are x's that are multiplied together. So that's why it's x squared, not 2x. Okay. Sometimes students get confused by that. Okay. As you go through that, you'll start to see it make more sense, I think, with practice. It also just know that your GCF, when you're looking at the variables, the letters, the variable can't be bigger than the smallest one. So like here, the smallest exponent is a 2. So I know the most these can have in common possibly is a 2, is x squared, x to the second power. Here in the next one, the biggest they'll possibly have in common is x to the first. So we'll see if that's what it is after we do the numbers. So again, we've got 2 over 4, and yeah, these are pretty straightforward, I know, but pretend they're big numbers that you didn't just see it necessarily. So if I put in 2 over 4, because that's the 2 numbers I have here in my calculator, that reduces to 1 over 2. So I can do the top number divided by the bottom number and see what my GCF is. It's 2. Or I can do the bottom number divided by the bottom number and the answer and see that I get a GCF of 2. So your GCF's the same regardless of which one you pick to divide. Okay. GCF is 2. So those will both pull out a 2. And then here we've got x to the fourth, so there's 4 x's there, and here we've got just 1, so we've got 1 in common, so 2x. All right, so looking at the directions, it says factor the common factor out of each expression. So we found the common factor, so now let's do something called factoring it out. Okay, factoring it out it's like dividing it out. That's the way I think of it. So I'm going to take it and go, okay, let me divide my GCF. 4x to the second, 4x squared. Okay, so if I'm dividing, 4 divided by 4 is 1, and a lot of us think of that as canceling out. Now, what we have here is 4 x's on top. 4 over 2, oh, whoops. Move you over if I can. two x's on the bottom because it's x squared, okay? Now, those x's cancel, those x's cancel. That leaves me with x times x on the top of the fraction, so to speak. So the only thing that I'm left with here is x squared, x times x. So let me put the answer over here. So my GCF was 4x squared. And I was left with no numbers. The 4 divided by 4 canceled. 4 divided by 4 is 1. The only thing I was left with was two x's multiplied together. So that's x squared. Okay. All right. On the next one, negative 12 divided by 4 is negative 3, because you know that negative 12 divided by 4 is negative 3, right? And then we've got x squared over x squared. Well, those cancel each other out. Or you can think of it as x times x over x times x, and those would cancel each other out. So they're gone. They're just gone, wiped out. And so that's it for my answer. So this is the answer to this problem. Now, let's think about for just a second that answer looks like a problem that we were just doing. If we slide back up here, that looks kind of like these problems where we were finding each product, okay? So we were given a problem where we had to multiply because we had parentheses and we had distributive property, and we ended up with answers that look like these. And what we have now is that we're starting with what looked like an answer before, and we're ending up with what looked like the problem before. So by factoring, we're just undoing that multiplying. That's why I said it's a lot like division, because it's kind of undoing the multiplying. Okay. So I hope that helps. There's other ways to do the variable part, and so I think I'm going to show you that on this one, just so you can kind of see that. So I'm going to take this, and I'm going to divide out that GCF. So 2x plus 4x, divide 2x. All right, make sure you're clear on where this came from. Here's 2x to the fourth plus 4x. I've written it over here. And then divide by 2x because that's my GCF. That's what I can pull out of both of them without, let me just say, that's what I can take out of both of them. I'll leave it at that, okay? So 2 divided by 2 is 1. Those cancel. That's the way we think of it a lot of times. So I know it's going to be the GCF out front, parentheses. 2 divided by 2 is 1, so that's gone. Now, I've got to think about, I've got x to the fourth, and I've got just one x down here. You might have noticed before that what we got was the answer you get when you subtract those exponents. So here we had x to the fourth over x squared. 4 minus 2 is 2. And we got x to the second. Here it was x squared over x squared. 2 minus 2 is 0. And we ended up with no variable, zero variables, you could think of it as. All right, so here, let's do that. Let's use that method here and see what we think about that. So x to the fourth over x to the first, let's subtract those variables. 4 minus 1 is 3. This is going to be x cubed, x to the third. And then we've got a plus. 4 divided by 2 is 2. X to the first over x to the first. 1 minus 1 is 0. So we have no x's left. So it's just the plus 2. All right. That's our answer. So one thing I didn't say is that you could take these answers and you could distribute them, and you should get the problem. Oh my. You should get the problem that you started with. Okay. In other words, you could check your work and know if it's right or not. Because if we multiply this together, do the distributive property, combine our like terms, this is what we end up with. Same thing here. Okay. Let's look at a couple more problems like this. In fact, several more problems. I think I have a strategy for all of these because these are longer. They even have, a couple of variables going on. So there's a lot more to think about in some of these. When they're longer, you can't necessarily put them all into a fraction on your calculator. That doesn't work in the same way. You can still possibly use that calculator for sure, but just you got more than two numbers, so you can't make a fraction that will help you that's bigger than that. So, okay. So this is going to bring out some of those rules that you might have learned when you were younger about division. They're called divisibility rules. And when I look at this problem right here, you know what? I'll tell you what. Let me do this a different way. I'm going to show you something different. I'm ready to change colors. It's not much of a difference, but okay. So here's what I'm going to do. In general, this is going to work every time. And so I want to go with that because that's kind of been my theme throughout this process. So 15 and 50 and 20. Now, if they had been negative, I'd put the negative in front for sure, but they're positive, so I don't need to do that. And I'm going to draw an upside down little division sign for now. Okay. And I'm just thinking to myself, okay, will all these divide by 2? Now, you probably know that they've got to be even numbers, 2, 4, 6, 8, 0. They've got to end with those numbers. And 15 is not even. It's odd. So these are not going to divide by 2. So then I would try the next number, 3, and think, okay, well, these divide by 3. Well, 15 divides by 3. And when I say will it divide, I mean without a decimal or a fraction as your answer. So 15 divides by 3. Let's try 50. 50 divided by 3 is going to give us a decimal or fraction answer. It's not exact. That doesn't work here. This is like a time in math, and there are a few, but not many, when you can say, oh, it's a fraction, not doing that. So, all right, so 3 doesn't work. What about 4? Well, 15 divided by 4, that's going to give me a decimal. So what about 5? 15 divided by 5 is 3. 50 divided by 5 is 10, and 20 divided by 5 is 4. So these will divide by 5. So let's put that out here. We've got 5, and 15 divided by 5 is 3, and 50 divided by 5 is 10, and 20 divided by 5 is 4. And then you want to think, okay, let me start over with 3, 10, and 4. Is there anything that'll divide into all three of these? Now, I will give you a little tip here. 3 and 4 are numbers that are in order when you count. That means there's nothing that will divide into all three of those numbers. Anytime you have two numbers that are counting numbers like 3, 4, or 18, 19, or 100 and then 101, anything that's in order means they're not going to have a greatest common factor. The biggest thing you can divide them by is 1, and we know if we divide by 1, it doesn't change anything. So what did this do for us? It did a couple of things. One is we now know the GCF is 5 for the number part. So I know that the GCF for this is 5 because that's the only thing that would divide out of all three of them. But I've also kind of got my answers to the part once I do the parentheses at the end. I already know it's going to be 3, 10, and 4. So that's kind of nice that that part's done. All right, let's look at the variables. We've got v to the third, v to the second, and v. So what do they all have in common? Do they have one v in common? Do they all have two v's? Do they all have three v's? Do they all have four v's? No, they all have at least one, but they don't all have at least 2 or 3 or 4. So just one v is what's in common there. Okay, so now I'm going to take this and divide by 5v. So I'm dividing the original problem by the GCF. And so my answer is going to be 5v times 15 divided by 5. We know that's the 3 that we already got here. And think v to the third over v. There's an understood 1 here. So 3 minus 1 is 2. So it's v to the square. To the second or squared. And remember, you can think of it as v times v times v over V, and one of those goes away and you're left with two of them. So if that, do the way that helps you understand it the most and the best. That's what you need to do. Because I'm telling you now, this is going to be big for a lot more things in algebra than just the section. And it's really huge in algebra 2. So it's not going to go away. If you are strong on it now, you're just going to be thanking your algebra 1 self. You're going to be looking back and being like, thank you for putting in this effort, because this is really going to make a difference. All right, here we go. So 50 divided by 5, we know from right here that is 10. And v squared over v, so 2 minus 1 is 1v, so just a v. And then 20 divided by 5, we know is 4. And the v's cancel out. No, undo. All right. So there is our answer. And again, we could distribute that 5v and do what we were doing in the multiplying section and see if we get the answer that was the problem that we were given to begin with. See if it matches the problem. And then we'd know that we did it correctly. Okay. So the thing that I almost mentioned to you earlier was that all three of those numbers ended with a 5 or a 0. And so, if you know that shortcut, that little rule, it's really nice. That doesn't mean it's the GCF every time, but it does mean that if everything ends with 5 or 0, then it'll at least, it'll at least divide by 5. So that's kind of cool because, think about your 5s, 5, 10, 15, 20, 25, 30, 35, 40. All those numbers end with a 5 or a 0. So if all your numbers in the problem end with 5 or 0, you can go ahead and just know, well, I can at least divide by 5. And then I can look at those smaller numbers and think, okay, is there anything there that I can divide now? An additional number. Okay. And we're going to see that in some of these. So let me pull this over. All right. So now we've got 30, 24, 60, and 30 again. And that one's a negative 30. So let's do what we did before. 30, 24, 60, and negative 30. And I just want to divide. And I'm going to start off with 2 because I see that these are all even numbers. So they all end with a 0, a 2, 4, 6, or 8. In fact, they're just zeros and a 4. So I know they'll divide by 2. 30 divided by 2 is 15. 24 divided by 2 is 12. 60 divided by 2 is 30. Negative 30 divided by 2 is negative 15. Okay. So now I'm thinking, all right, will these numbers divide by 2? Because we're just going to keep going and do the same thing. But 15 is odd, so it's not going to divide by 2. So let's go up to 3. Yep, 15 divides by 3. 12 does, 30 does. Oh, cool. All right, so 3 works. So 15 divided by 3 is 5. 12 divided by 3 is 4. 30 divided by 3 is 10. Negative 15 divided by 3 is negative 5. Okay, so what do you notice now? 5, 4, 10, and negative 5. If you remember what I said, you've got counting numbers. This time we have 4 and 5. Those are right next to each other when we're counting. That means there's no more GCF. So I'm done. So I know that. And what I have here is a 2 and a 3. And so my GCF is going to be whatever 2 times 3 is, not 6, because I was already thinking ahead. So 2 times 3 is 6. So that to me makes this process of finding GCF the simplest I've ever seen. Okay. I know that if I can just keep multiplying out these little numbers, then my GCF is going to be those numbers that I pulled out, multiplied together. That's my GCF. And that is a much faster process than sitting there and punching numbers in your calculator for days and days. Like, oh, let me try this number. Let me try this. Well, does it work for this other one? I don't know. Let me try that one, Because, these are fairly small numbers, even though they're a lot bigger than 2, 3, 4, 5. Relatively, they're small compared to a lot of the numbers that you're likely to see. So this works every time to find the GCF. So now I just need to figure out the variable part for the exponent yeah, all that stuff. So I've got a to the fifth, fourth, third, and second. So think, what's the most number of a's they have in common? It's that smallest exponent. The most they have in common is a squared. So my GCF is 6a squared. So if you had to name the GCF, there's that part. So we're going to divide by 6a squared, and we're just going to factor it out of every section or every term here. Okay, so when we do that, we've got 6a squared in front of the parentheses, and then we're just dividing out. And remember that all of our numbers are going to match right here, because this is where you've divided out a 2 and a 3, which is the same as dividing 6. So this leaves me with 5a to the, think about it, a to the fifth over a to the second. You had 5 and you took 2 away. So you're left with a to the third plus 4a. You had 4 on top. You had 2 on the bottom. So 4, you took 2 away. That leaves you with 2. And then 10. 3 minus 2 is 1a. And then these a squareds cancel each other out. 2 minus 2 is 0. So there are 0 a's in our answer. And it is -5. And all right. And so we are done with that one. And yep, that's it. All right. 2 more to go. Let's see here. Okay, so we've got 32, -32, and -72. So I'm going to write those down and divide. And 2 is 16, and -16, and -36. Even numbers again. 2s, so 8 and -8. -18. Ooh, 2 again. They're still even numbers. That works. All right, 4, 4, and 9. -4, -9. 2's not going to work because 9's odd. And then 3 doesn't work because 3 doesn't go into 4. And then 4 doesn't go into 9. So we're done. So the GCF is 2 times 2 times 2, and don't say that 6. Red students tell me that many, many times. All right, 2 times 2 times 2 is 8. So 2 times 2 is 4, times 2 is 8. So my GCF is 8. Now, oh my goodness, we've been going along okay, and now all of a sudden we have U and V. There's 2 variables. It's okay. You're still going to do the same process. You just have to do it for both of them, but keep it separate. Don't think of it as UV. Think of it as a U, figure out the U's, then think about the V's and figure those out. So we've got U to the third, U to the second, and U to the third. So what's the most number of U's they all have? They all have at least, I think I said U to the second here in the middle, but they're all U to the third, aren't they? U to the third. So they have U to the third in common. They have 3 U's. There's 3 U's in all 3 of these terms. All right, V to the fifth, V to the third, V to the second. So how many V's do they have in common at the most is V to the second. So there's my GCF, 8U cubed V squared. Okay, so we're going to, let me change the color here. We're going to divide by 8U cubed V squared through the whole thing, each one. Okay, so 32 divided by 8. Let me find a place down here to put this answer where it's a little less confining. All right, 8U to the third V squared. I know that the GCF goes out in front every time. I think I'm pointing this way when this is your left side. All right, so I know that comes out in front every time. So I'm going to put that every time in the front before the parentheses. Now, 32 divided by 8, there's my numbers. So 4. And then I've had 3 U's and I took 3 U's away. So U's are just gone. There were 5 V's. I took away 2 of them. So that's 5 minus 2 is 3. And then the next number is going to be -4. And then 3u's and 3u's, that goes away. 3v's and then 2v's. So I had 3. I took 2 of them out. That leaves me with 1. And then I have a -9, 3u's and 3u's. So those just go away. And v squared, and I take away a v squared. So just a -9 there. All right. So that is my answer. That is factored as far as I factored out the GCF. Okay. So let's take a look here at the last one, 48, 54, and 42. I don't know why I started with the next one. 48, 54, 42. Okay. So I'm going to start by doing what I've been doing. These all divide by 2 because they're even. So divide by 2, 24, 27, 21. Okay, so now I'm going to divide by 2 again if I can. 24 is even, 27 is not. So can't divide by 2. So then try 3. So 24 divided by 3, that'll work. 27 divides by 3, 21 divides by 3, so I can do 3. So let's see, 8 and 9 and 7. Those are counting numbers. All 3 of them are 7, 8, 9. So I know that I'm done. So I've got a 3 and a 2, and that's going to give me my GCF. 2 times 3 is 6. Okay. And now I'll start to look at the variables. Now I've got x to the third, x to the fourth, and x to the third. So what's the most that they have of x's in common? They all have at least 3 x's. So x to the third. And then this is a y squared, no x, no y, and no y. So do they have a y in common? No, just that first term has a y. The others don't even have that, so that's not part of the GCF. So my GCF is 6x cubed. That's what I'm going to divide out here from each part of this trinomial. Alrighty, so I'm going to put my answer down here. 6x cubed. All right, and then remember, here's my numbers. It's already done for me. So I've got 8, and then x cubed divided by x cubed. Those go away. Had 3 x's, took away 3 x's. There's no x's left. And then I've got the y squared. And then the next one, 54 divided by 6 is 9. Have 4 x's. I take 3 away. That leaves me with 1. And then the next one, or the last one, 42 divided by 6 is 7. I had 3 x's and I took all 3 of them away. So there's no x's left in that final answer. All right, that's it. Whew, that's a lot. I hope this has helped you to prepare for polynomials test or to understand the notes that you're learning in class better, and even if you're not quite there yet. And I also hope that you've realized, because I told you, that factoring is going to be a really important part of more things in Algebra 1 and a lot of stuff in Algebra 2 and beyond. So you want to be strong on this GCF. You want to be strong on the factoring out the GCF process. And I'd be glad to show you more examples and help with that. Just let me know if, that's what you need to see. All right, thanks. Bye.